Boom! Hey, how's it going? Alright, today we're going to talk a little bit about what we call a 5-number summary. I'm not going to do all 5 numbers in this summary, I'm just going to do a couple. And here's a list of what we're doing. Now, if you count, that's not exactly 5, but I'm not lying. Only a few of these are part of the 5-number summary. Now, what am I talking about? What am I talking about? When I collect or do a survey, okay, I don't go to everybody and tell them the whole data set that we're talking about. So if I do a survey, for instance, how many jackets does everybody wear? I don't go around and tell everybody the 200 results that I got. Okay? What I do is I summarize it. I try to condense it so it's easier to pass on. And also gives me a bigger picture of the group of people I'm looking at. All right. So what I've done here is I'm simulating 2 different groups. Okay, and we can stick with the jacket scenario. How many jackets do you have in the winter? Why would this be important to know? Perhaps you do the survey to get an idea of if a coat drive would be beneficial for a particular group or a particular area. This could have been, how many scoops of ice cream do you like to eat? Also helpful if you want to plan a nice ice cream party, right? So here's group 1, here's group 2, and here's how we summarize this information. First number that most people like to summarize with is, well, what's the average? If I were to get an idea of how many jackets I could expect one person in this particular group to have, what would that be? So if I went and asked the next person, I could guess or predict what their answer might be, or how it'd be close to a certain number. All right, we find the mean first. Okay, mean is average. Basically, add all your numbers together, divide by how many you're adding together. Okay, that's your mean. Something that you've done regularly in previous grades. So we'll just demonstrate that really quick. 2, 3, 4, 4, 6, 6. Add those all together. These are 6 people who gave results, right? So we add all their results together. 2, 3, 3, 4, 6, 6. When you add all that together, you get something to the effect of 10 plus 19, that's 19, 22, 24, right? And then divide by how many you've added together. Divide by 6. This results in 4. The average number of coats people tell you they have is 4. So here's your mean, 4. Alright, you can do the same thing on this side. Find the average or find the mean. Those are synonymous words. Meaning they're the same. They mean the same, have a similar meaning. So add these together. Again, there's 6 of them. 4, 3, 4, 3, 4. Nice pattern. I like it. Add this all together, so this is 10, 24. Wow, that's also 24. That's interesting. Okay. So your mean is also 4. Okay, we're going to put that right here. Okay. These other 3 or other 4 parts are part of what we call a 5-number summary. I didn't put the 5th one down here. I'm just going to start you off basic and simple and try to keep this short, sweet, and to the point. Okay. Sometimes, if we have a larger set of data, one number is not enough. Okay. If, for instance, I took a survey of goodness. I took a survey of how many cars people have driven in their lifetime. I will get a ton of different answers. And it depends on how old the person is, how young the person is, depending on how long cars have been around, and the economic state that they live in. One number may not be enough. I may have to go with a range of numbers. I say most people have driven anywhere between 2 to 5 cars in their lifetime. That's a guess, an estimate, or that's a complete random assumption about that range. However, that's a range. It's not just one number. So how do we come up with that range? Well, I'll show you. First, what you're going to do is you're going to divide your data into 4 quarters. Okay, and then you're going to find the middle portion, the middle half of your data, which is between the first and third quarter, and we call that the interquartile range. Okay, So that's good. The range is what we really want. But in order to find the range, we have to find these other three pieces first, which is why I wrote them first. All right? So I called these quarters because that's what we're going to divide the data into, 4 quarters. We're going to start with the median. The median is another way of saying the middle. What is the middle number? All right, well, let's take a look here. I'm going to erase this because this is just my scratch work, honestly. First thing you got to do, you got to arrange these numbers in numerical order to find the middle number. Okay? These ones aren't arranged in numerical order, so if I just picked a random middle number here, it may not line up very well. So we're going to pick the middle number of a set of numbers in numerical order. 2, 3, 3, 4, 6, 6. This is in order from least to greatest. The middle. So there are 3 numbers on each side, so the middle is going to be right here, right between 3 and 4. Well, that makes it a little bit tricky. So what we're going to do is we're going to average 3 to 4 together. What's right in the middle between 3 and 4, like right halfway? If you're not sure, find the mean of those 2 numbers, 3 and 4. 3 plus 4 is 7. 7 in half divided by 2, that's 3.5. Or if you just see it right off the bat, that's 3.5. Okay? 3.5 is our median here. Alright, so that's nice. Over here, we have to arrange this in numerical order first. So let's do that. Let's start with lowest. So we have 3, 3, 4, 4, 4, and 6. Alright, that works. So it's now in order from least to greatest. Find the middle number. Well, there's 3 on each side. The middle is going to be somewhere between 4 and 4. Well, that'll be pretty obvious. Between 4 and 4, it has to be 4. Okay, so right here, the median is 4. Now notice that the middle number is not always equal to the average or the mean. Okay, and there's a purpose for that. If I had some weird extreme value like 13, and when I added all those together, my mean would be higher. But the median would still be 4. Okay? So sometimes when I have extreme values, we call them outliers. They make the mean shift, okay, which could throw off your estimations. The median sometimes is more accurate if you have these extreme values. Alright, so that's the purpose of that. I'm going to erase that 13, but we're not going to worry too much about it right now. Well, how about this other piece? So what I've done here is I've divided this in half. I got 2 halves. Remember what I said, we're going to divide it into quarters. So I need 4 quarters. First quarter. Well, take that first half and find the middle of it. It's kind of like finding the middle of the first half. Well, 1, 2, 3. Well, the middle number here is 3. Again, you have to have them in numerical order, which we already did, so we're good. This would be your first quarter. I just say first cube. Okay? So your first quarter here is 3. Over here, also your first quarter here is 3. Alright, so that's not too hard. Find the first quarter, find the median. Now we're going to find the third quarter. Why is it the third quarter, not the second quarter? Well, look. First quarter, second quarter, third quarter. And then fourth quarter we don't need to find it. We'll already have it once we find the third quarter. Alright, so let's see. Again, if you got the middle of this first half, find the middle of the second half. So 3 numbers, the middle number is right here. That is the third quarter. Okay, which is 4.